guys, welcome back. In this video, we'll be discussing discriminants and roots of quadratic equation. Let's get started. So this is the general form of a quadratic expression equated to 0. And if you need to find the roots, you could use the quadratic formula to get the roots. Now, this thing right here, b square minus 4ac, this is called the discriminant of the equation. Now, b square minus 4ac tells you how many roots will a particular quadratic equation have. Let's talk more about that by doing these three examples. So in the first one, if I need to find the solution or the roots of this quadratic equation, I am using quadratic formula in this case. So a is 16, b is minus 8, and c is 1. So the quadratic formula will be x is equals to, this is the quadratic formula, minus b means minus 8 is plus 8, plus minus b square is minus 8 whole square, which is 64, minus 4, a is 16 and c is 1 upon 2 times a, which is 16. So notice that this value right here becomes 0. 16 minus 4 times 16. So, 64 minus 4 times 16 is 0. So, in this case, the discriminant is 0. b square minus 4ac is 0. So, this does not exist. So, 8 divided by 8 plus minus 0 is just 8. Divided by 2 times 16 is 32. So this just becomes 8 upon 32, which is 1 upon 4. So there's only one root or one solution to this quadratic equation. Why is that? Because in this case, the discriminant is equals to 0. And graphically, this would mean that the curve would touch the x-axis at only one point. So when the discriminant is 0, there is only one solution to the quadratic equation. Okay, let's do the second example. In the second one, a equals 1, b equals 2, and c equals minus 3. So x equals minus b plus minus b square minus 4ac upon 2 times a. So this discriminant is equals to 4 plus 12, which is 16. So we get x minus 2 plus, x is equals to minus 2 plus minus, what is square root of 16? Square root of 16 is 4 divided by 2. So we're getting two answers. One answer is minus 2 plus 4 divided by 2, which is 1. And the other answer is minus 2 minus 4, which is minus 6 divided by 2, which is minus 3. So now, in this case, we got two solutions of the quadratic equation. Why is that? Because now b square minus 4ac came out to be greater than 0. And graphically, it would mean that the quadratic equation is cutting the x-axis at 2 points. In fact, it's cutting at minus 1 and 3. So the quadratic equation or the graph of the quadratic equation would look like this. So in this case, the graph cuts the x-axis at 2 points when b square minus 4ac is greater than 0. All right, let's do the third one now. So for the third one, a is 1, b is 2, and c is plus 5. So x equals minus b plus minus square root, b square is 2 square 4, minus 4 a c divided by 2 times a. So x equals minus 2 plus minus, this becomes 4 minus 20, which is minus 16 over 2. Now in this case, the discriminant is less than 0. B square minus 4AC is less than 0. Now if you try entering square root of minus 16 in your calculator, you'll get math error. So whenever B square minus 4AC is less than 0, no real solution exists. So you can't solve this quadratic equation to get a real solution. Right. So let's quickly recap, and also graphically this would mean that the curve never touches the x-axis. It's either like this or it may be an upside down U, and this curve will never touch the x-axis, so that's why no solution exists. Okay, now let's recap what we've done so far. All right, so let's recap all the cases. So when b square minus 4ac is equals to 0, that means that the curve touches the x-axis at only one point. So the exam question might have a statement like this, that x-axis is tangent to curve, or it may say that two real equal roots exist, that there are two roots but they both have the same value. So that's why the graph seems to be cutting the curve at only one point. So the two roots are repeated roots. So in that case you must use b square minus 4ac equals to 0. Now when the question says that there are two real distinct roots, or the quadratic equation cuts the cuts the x-axis at 2 points, that implies that b square minus 4ac is greater than 0. And when the question says curve does not meet the x-axis, or 0 real roots, or curve lies above or below the x-axis, that means in this case b square minus 4ac is less than 0 and no real solution exists. Similarly, you might be told in the question that the roots are real. Now the roots are real in this case and the roots are real in this case. So then you write discriminant b square minus 4ac is a merger of both of these, equals to 0 and greater than 0. So you write greater than equals to 0 when the question states real roots only. You're not told whether they're two distinct roots or two repeated roots. So then you'll have to use greater than equals to 0. All right. Now let's do some past paper questions from this topic. Okay, find the set of values of k for which 4x square minus 4kx plus 2k plus 3 equals to 0 has no real roots. So it's this case where the graph is either above the x-axis or below the x-axis, that is no solution exists, and that is when b square minus 4ac equals to 0. So let's see what is A, what is B, and what is C in this quadratic equation. So A is 4, B is minus 4k, and C is this entire thing 2k plus 3. So let's equate it here, substitute these values here. So minus 4k whole square minus 4, A is again 4, and C is 2k plus 3, and equate it to 0. I'm sorry, my bad. When there are no real roots, that means that b square minus 4ac is less than 0. It's less than 0 and less than 0. So 16k square minus 16 times 2k plus 3 less than 0. I'm going to make this question less complicated by taking 16 common, or by just dividing both sides with 16. So this gets divided by 16, it becomes 1k square minus this becomes 2k plus 3, and this side gets divided by 16 and it's just 0. So the inequality is k square minus 2k minus 3 is equals to 0. So sorry, less than 0. So it's k square minus 3k plus k minus 3 less than 0. So k is common, k minus 3, and plus 1 is common, k minus 3 less than 0. So k minus 3 bracket k plus 1 is less than 0. If you find the critical values of k, they are 3 and they're minus 1. I hope you've seen my video on solving a quadratic inequality. If you haven't, please go watch it. And right now we're just solving it. So since it's less than 0, we write k is less than the smaller number, and k is, no, in fact, it should be written like this. K in between smaller number over here and bigger number over here. So this is the solution of this question. All right, next question. So here it says, find the value of k for which this equation has two distant real roots. So we're talking about this case where the curve cuts the x-axis at 2 points. So this happens when b square minus 4ac is greater than 0. So that's how we'll start the question. B square minus 4ac is greater than 0. So b square minus 4ac is greater than 0. Now this is b, k plus 9. So k plus 9 whole square minus 4, a is 1 and c is 9 is greater than 0. So this is k plus 9 whole square minus 36 is greater than 0. So for a while, I'll forget that this is a question on inequality and I'll treat it like an equality. So this becomes equals to 36. Now, instead of expanding the left hand side and then solving the quadratic equation, what I'll do, I'll take square root on both sides. So k plus 9 equals plus minus 6, which means one value for 6 is k is minus 3 and the other value for k is minus 15. Plus 6 minus 15 and the other one is plus 3, sorry, minus 6 plus 6 minus 9 is also, both values are negative in fact. So we're getting k equals minus 3 and k equals minus 15. Now let's go back to the original question. The question is that the inequality is this, in fact, greater than 0. So we've already discussed that if the inequality is greater than 0, so then what you do, you write k is greater than the bigger value. Which two of these is bigger? Negative 3 is bigger. And then you write k is less than the smaller value, which is minus 15. So this is the solution for this question, that these are the set of values of k. K is either greater than minus 3 or less than minus 15. All right, another one. Find the value of k for which x-axis is tangent to the curve. So that's this case, x-axis is tangent to the curve. Or the statement could have been that the roots are equal, real and equal. So even then, it would imply that b square minus 4ac is equals to 0. Then you get this graph where the curve is tangent to the x-axis. Okay, so now let's substitute the values. B is this, so 2k plus 10 whole square minus 4, a is 1 and c is k square plus 5 equals to 0. So now let's solve it. So I'm going to expand this, a square plus 2ab, so 40k plus 100 minus 4k square minus 20 equals 0. So 4k square and 4k square gets cancelled. So 40k is equals to minus 80 and k equals minus 2. So that's the answer. All right, one last question from this topic. Find a set of values of k for which this equation has real roots. Now, real root means that it could be a case like this, where the curve cuts the x-axis at 2 points, or this case where the curve cuts the x-axis at 1 point. This is when b square minus 4ac is equals to 0. and this is when b square minus 4ac is greater than 0. So this has two real roots, two real and distinct roots, and this has either one real root, or you could also say that this has two real repeated roots. So in both the cases, you need to merge both the cases, because in both the cases there is a real solution. So in this case, the discriminant is greater than equals to 0. So b is k minus 2 whole square minus 4, a is 1, and c is 2k minus 4. So equate greater than equals to 0. Now let's solve it. So this is going to be a square minus 2ab plus b square minus 8k plus 16 greater than equals to 0. So that's k square minus 12k plus 20 greater than equals to 0. I'll first just solve this quadratic equation, ignoring the inequality. So the factors will be k square minus 10k minus 2k plus 20. Let's equate it to 0 for now. So k is common, k minus 10, minus 2 is common, k minus 10 is equals to 0. So k minus 2, k minus 10 equals 0. So k equals 2 and k equals 10. Now, since the question is on inequality and it is greater than equals to 0, so like discussed in the video on inequality, now you'll write k is bigger than equals to the bigger of these two numbers, which is 10, and k is less than equals to the smaller of the two numbers, which is 2. All right, that's it from this topic, and I'll see you next time. Take care.